Okay, welcome back. Vaishnav join ചെയ്തോ? ഇല്ല. Yeah, Vaishnav. I was asking you to summarize the class, what we have learned in the third hour, right? Vaishnav, are you
Hello.
hearing?
Hello.
Okay. Tell what we have learned in the last class.
Physical layer le പഠിക്കാൻ പറഞ്ഞേ ഫംഗ്ഷൻ
കഴിഞ്ഞ ക്ലാസ്സിൽ എന്താ പഠിച്ചതെന്നുള്ളത് ഒന്ന് സമ്മറൈസ് ചെയ്യുക. Vaishnav?
ശരിയുണ്ട്.
Yeah, tell.
ഫസ്റ്റ് ട്രാൻസ്മിഷൻ മീഡിയ.
Okay.
ഫിസിക്കൽ ലെയറിനെ കുറിച്ചിട്ട്.
Which layer is responsible for the control of transmission media?
ഫിസിക്കൽ ലെയർ.
Huh?
ഫിസിക്കൽ ലെയറും ഡാറ്റ ലിങ്ക് ലെയറിനെ കുറിച്ചിട്ട്.
അതിൽ ഏത് ലെയർ ആണ് ട്രാൻസ്മിഷൻ മീഡിയ കൺട്രോൾ ചെയ്യുന്നത്?
ടോപ്പ് ലെയർ.
Which is the layer that controls the transmission media?
Physical layer.
Physical layer. Okay. Now, what are the responsibilities of physical layer?
Frame is converted as signal.
Louder, little louder.
Frame is converted as signal.
Okay.
Take care of physical network.
What the main thing is, it has to provide service to the data link layer. Adaida, you will be getting a stream of bits that you can call it as a frame in data link layer, and that frames or the stream of bits should be converted to a suitable form for transmission, and that is done by the physical layer. Okay. Now, what are the two types of media? Transmission media.
Guided media.
Guided and
unguided.
Unguided.
But guided in a moonite class.
Okay. What are the three?
Guided in a moonite class.
Yeah.
What are
twisted pair, coaxial cable and fiber
optic cable.
Optics. Okay.
Optic cable. Unguided air.
Okay. See, those who are joining late, next class onwards, I'll be marking absent because 12:10 in a class. Now time is 12:15. So 5 minutes later, attendance is on time. See, half an hour break you or 2 minutes. 12:10 in a class 12:08 in a join jayan sramikia. Okay. Now answer your attendance, Afla.
Present, miss.
Ajmina.
Yes, miss.
Amaya.
Present, miss.
Yeah. Atulya. Drishya. She has not yet joined, I feel. Okay, Jyotish. Karthik.
Present, miss.
Karthik ano Jyotish ano parne? Karthik.
Karthik.
Kavya.
Present, miss.
Nachiket.
Present, miss.
Neeraj. Rangeet. Vaishna K. Vaishnav. Anjali.
Present, miss.
Shruti.
Present, miss.
Okay. So Atulya P has not answered. Then Drishya, Jyotish, Neeraj and Vaishna.
Mr. Pasanda.
Vaishnava? Okay. Mm, 30. See, if you are late for some valid reasons, you can just message me what was the reason for not joining the class. If it is valid, I will consider, otherwise I will be marking absent. Okay. Now, we will start the class. So we were dealing with the guided, one of the guided media, that is called it as the twisted pair cable. And tomorrow you all have to answer one by one what are the I am assigning the questions for you. Register number 1 has to answer what are the responsibilities of physical layer, and 2 has to answer what are the different types of transmission media. Then 3, you have to answer what are the advantages, disadvantages, and the application of the twisted pair cable. And 4, what we are going to see now, the coaxial cable, and the fiber optic, some portion if I'm covering, that also register number 5 has to answer it. So prepare for the class, and the slides I'll be sending it to you today itself. So refer to that slides and study, read the textbook. It is from the chapter 7 of 407. The physical transmission media. Okay, you can just go through it. Okay, now the next type of guided media is the coaxial cable. Coaxial cable, in short, you can call it as coax. Now you can see the diagram of a coaxial cable. Actually, this coaxial cable, it carries high frequency range signals. The other one, it was limited with the frequencies, but here it carries high frequency range signal. Now you have got a central core conductor. You can see in the diagram, an inner conductor is specified. So you have the central core conductor, and that is enclosed in an insulating sheath. You have a sheath there, and that is encased in an outer conductor. That is nothing but a metal foil, braid, or a combination of that thing. And this outer conductor, it acts as a shield. Okay. Now, this is also enclosed in an insulating sheath. And finally, the whole cable is protected by a plastic cover. So this is how the cross-section of this coaxial cable is going. You have an inner conductor. Okay. You have a sheath, both, insulating sheath, and you have an outer conductor. An outer conductor, it acts as a shield against noise, and the whole thing is enclosed in a plastic cover. Okay, it is protected by a plastic cover. Now you can see just the cross section of the coax layers. You can see the outer jacket, that is polyethylene, made up of polyethylene. You have a shield, which is braided wire, and you have an insulating material, and you have a conductor, which is either copper or aluminum. Okay, so this is just the cross-sectional view of a coaxial cable. Now, this coaxial cable, I told you have a central conductor, you have an outer conductor, and the frequency range it supports is from 100 kilohertz to 500 megahertz. It supports a frequency range of 100 kilohertz to 500 megahertz. Now, same like twisted pair cable, here also you have got different categories. So categories of coaxial cable. Actually, this coaxial cable is categorized by their RG ratings. RG means radio government. So each radio government, what it specifies is you have a unique set of specifications there. Actually, specifications in the sense it is the by means of wire gauge, what is the thickness of the wire, and you have got an inner conductor, and what is the thickness of that inner conductor. You have a type of the insulator, what insulator you are making use of, and what type of outer casing you are making use of. So all these are specified by the radio government. And if so, the different categories are RG 59, 58, and 11. Now RG59 cable, mainly it is used for use in cable TV, and 58 in thin Ethernet and thick Ethernet. Later you'll be studying in this module what is this thin Ethernet and thick Ethernet. So at that time I'll just tell you what it means. Okay, so just understand you have got various categories of coaxial cables, and that is specified by the RG ratings, and that RG ratings means specific function specification is there in terms of your thickness of your wire gauge, the type of the inner insulator or the thickness of the inner conductor, or the outer type of the outer casing you are making use of, etc. Okay, so if you are doing these specifications, you have got various categories like RG 59, 58, and 11. Okay, now next is the connectors. Connectors, what was the connector in twisted pair cable? What was the name of that connector? Can anybody answer? What was the connector in twisted pair cable? In what name you are noticing that? Karthik.
UTP, STP.
Louder.
UTP, STP. UTP, STP.
UTP, STP, they are the types of the cable, twisted pair cable. I'm telling the connector, how you are connecting that twisted pair cable to devices. What type of connectors you are making use of?
RJ45.
Yeah, you have registered jack, that is RJ45 connector. You can have a male connector as well as a male connector. So similarly, for coaxial cable, you are making use of BNC connector. BNC means Bion Neil Concealment. That is called as the full form of this BNC. Actually, if you want to connect your cable to devices, you need some connection, and that is done with the help of some BNC connectors. Now, this BNC connectors are of three types. One is BNC connector, the other one is BNC-T connector, and the BNC terminator. Now, where you are making uses in cable TV networks and in some LANs like thick Ethernet and thin Ethernet, you are making use of this coaxial cable. Okay, so you can just see in the diagram what is the shape of those connectors. Okay, so I was discussing about coaxial cable and what is its connector. Now what is the transmission characteristics of the coaxial cable? As if you are making use of analog transmission, you have to make use of amplifiers every few kilometers, and it supports a frequency range of 500 megahertz. Now, digital, instead of amplifiers, you are making use of repeaters. Okay, so this is the transmission characteristics of the coaxial cable. Now what are the applications where it is being used? Just now I have told in LAN networks you are making use of it, and you are making use it in television distribution. That is where the cable goes from aerial to your TV or your cable TV. They make use of this coaxial cable. Then for long distance telephone transmissions, you are making use of this coaxial cable. Simultaneously, it can accommodate almost about 10,000 voice calls. Okay, now it has been replaced by the next type of guided media, that is nothing but the fiber optics. Okay, so these are the applications of the coaxial cable. See, once you study all this transmission media, what is the most important thing is you have to describe about that, what are its types. Then the main thing is advantages, disadvantages, and applications you have to specify for each guided media. If it is not asked also, you have to specify. Depending upon the mark, you have to write it. Okay. Now, so this is just a comparison of the guided medias, what we have learned now. So I have just told guided media, mainly it is of three types. One is the twisted pair, the other one is the coaxial cable, and the third one, which we are going to see now, is the fiber optic. Now, twisted pair and coaxial cable, what are the different types of twisted pairs? UTP, STP is there, and what are its advantages, disadvantages, and applications you have gone through. Now, coming to coaxial cable, it can support a high frequency range of signals. Now, what is the specification is you are having an central core conductor, and you have an outer conductor also that act as a shield to protect against from the noise. Okay, and all these things are protected by a plastic cover. Now you have got various categories of this coaxial cable that is specified by the radio government ratings. Now next, you have learned about the type of connector used to connect the coaxial cable to devices. That connectors are generally known as DNC connectors. Okay, understood this much? Yes or no?
Yes, miss.
Okay.
Yes, sir.
Yes. Okay. Now the next thing is you are going to study the third type of guided media, that is nothing but the fiber optic cable. Now fiber optic cable, you have studied in detail the optical communication, right? What is the working principle, how it works and all that Shajina Miss, I think she had explained to you. So fiber optic cable is made of glass or plastic and it transmits signals in the form of light. Okay, when you are comparing twisted pair and coaxial cable, they transmit signals in the form of electric current. But here it is made up of glass or plastic and it transmits signals in the form of light. And you know, when light travels in a single uniform substance, what shape it takes actually? It takes a straight line. It travels in a straight line. When it is moving through a uniform substance. Now, what happens if the density of the substance changes? What happens if it is moving from one density to another density area? Okay, so what happens is the ray changes its direction. Now you can see a diagram where the ray of light changes its direction once it moves from a more dense medium to a less dense medium. You can see in the diagram how the ray of light, what is the direction, what path it takes when it moves from a more dense medium to a less dense, when it travels from a more dense medium to a less dense medium. So in the first diagram, what happens when the angle of incidence, if it is less than the critical angle? Now, critical angle is nothing but it is the property of a substance, right? And its value changes from substance to substance. Now, if the angle of incidence, if it is less than the critical angle, what happens to the ray? The ray refracts and it is moving closer towards the surface. Okay. Now, what happens if the angle of incidence is equal to critical angle? If it is equal, the light will bend along the interface. It will bend along the interface. That property is called it as refraction. Okay. Now, if it is greater than the critical angle, what happens? The ray reflects. Reflects in the sense it travels again in the denser medium. Okay, so these are the three things that you have to understand in what direction a ray of light passes when it moves from a more dense medium to less dense medium, considering the angle of incidence and the critical angle. If I is less than critical angle, the ray will refracts. If I is equal to critical angle, it bends along the interface. And if it is greater than the critical angle, a reflection takes place. Now, this optical fiber, it uses the reflection property. Reflection property in order to guide light through the channel. Optical fiber make use of the principle of reflection to guide light through a channel. Okay, now you can see an optical fiber in the figure. Now here you have a glass or a plastic core and that is surrounded by a cladding. When you are comparing the core and the cladding, both will be of different density. One will be of less dense and the other one will be of the more dense. So you should select that materials, or the difference in density of the two materials are such that the ray reflects back. Okay, the one will be reflected off, and instead of when it is moving from one medium to another medium. So you are having a glass or a plastic core, and that is surrounded by a cladding. When comparing with the core, it is less dense than the glass or plastic, and core. Okay, now the difference in density of the two material must be such that the beam of light moves through the core and it gets reflected. Understanding? That is the working. This is how the ray of light passes in an optical fiber. Now, this is again the cross section, 3 concentric sections of a fiber optic lens. You have the fiber core, you have a glass or a plastic cladding, and finally a plastic jacket. Okay, now the very important one, the propagation modes of optical fiber. So generally, propagation mode is nothing but it is you want to propagate light through the channels, optical channels, and you can have different classifications like multi-mode and single mode. Multi-mode can be implemented in 2 ways. One is called it as the step index, and the other one is called graded index. Have you studied all this thing in optical? Yes or no?
Yes.
Yes. Okay. Then you will know better, right? Okay. So 2 propagation modes of optical fiber is the multi-mode and the single mode. Now multi-mode, again, it can be classified into step index and graded index. Now what is this step index, multi-mode step index? Multi-mode step index, you can just see the diagram how it differentiates each other. Multi-mode step index, multi-mode graded index, and a single mode. Now, when you are considering multi-mode step index, here the diameter of the core, when I tell each word, you should understand what it means actually. The diameter of the core is large when you are comparing with the cladding. You have a core and a cladding. The diameter of the core will be large when you are comparing with that of the cladding. Now, what about the density of the core? The density of the core is constant from the center towards the edges. The density of the core is constant from the center towards the edges. That is, the core has got one index of refraction. The cladding has got another constant of index of refraction. You know what is index of refraction? It is nothing but the speed of light in air divided by speed of light in the substance. So that is called index of refraction. So here you have got a constant index of refraction. Core has got one index and the other one has got a constant index of refraction. Okay, now what happens when a beam of light moves through it? So when a beam of light, when it moves through the constant density it moves in a straight line. You can see in the diagram. It moves in a straight line until it reaches the interface of the core and the cladding. Right? Understanding? A beam of light, once it moves through this constant density, it moves in a straight line until it reaches the interface and the cladding. Now what happens at the interface? At the interface, there is an abrupt change. Why? Because you have lower density at the interface. So there is an abrupt change, and that alters the beam's angles, that motion of that beam, right? So at the interface, what happens is you have got an abrupt change due to the lower density, and that changes the angle of beam's motion. Now, step index, the meaning of step index means you are having a sudden change. When it is the ray of light, when it passes, you are having a sudden change once it touches the interface and once it moves through the constant density. And that results in a distortion. Okay, once it passes through, you are getting the output with a distortion. So that is multi-mode step index. Step index means a sudden changes is occurring there, and that result in distortion of the signal. Okay, so step index, you have to just understand. First one I told us the diameter of the core is higher than that of the cladding. Second one, the density of the core is constant from center towards the edges. So when a beam of light, once it passes through this constant density, it travels in a straight line. But what happens when it touches the interface? When it touches the interface, you have having an abrupt change. And since there is a sudden change, that results in distortion of the signal. Okay. Now the next one is called the multi-mode graded index. Graded index means here you are having a degrees in distortion. Comparing with the step index, graded index is not having much distortion because the density is highest at the center of the core. At the center of the core, you are having higher density. And it decreases gradually at the once it reaches the edges. Okay, center of the core, you are having more density, and once it reaches the edges, it is of less density. Okay, so what happens to the ray of light? It bends smoothly. So near to the edge, it takes a longer path, but it travels faster. So you don't have much distortion when you are comparing with the step index 5. Okay, so graded index, the main thing is the density is higher at the center and it decreases gradually towards the edges. So once you are having a continuously varying index of refraction, the rays are bent smoothly. So distortion is less in this case. Now the third one is called it as the single mode of propagation. Here you have got a small diameter, right? You have got a smaller diameter and a smaller density. So what happens? Decrease in density, it results in the critical angle that is close enough to 90 degrees. So that means the beam lies almost horizontal, passes through a straight line. So almost identical, and therefore you won't get much delay at the destination side or the receiver side. Since the density of the core is very less, and since it has got small diameter, the beam of the light, it travels through a straight line. So all the beams, what all beams, they are propagating or they are arriving at the destination together, and you can recombine all these signals with little distortion. Okay, so these are the types of propagation modes in an optical fiber. One is the multi-mode step index, multi-mode graded index, and the other one is the single mode. Multi-mode step index, diameter of core is very large, but the density of the core is constant from center towards the edges. Okay, but when you are considering graded index, density is highest at the center and lowest at the edges. When you are considering a single mode, the density, it is of less density. So degrees in density results that the critical angle is lying which is close enough to 90 degree. It makes the propagation of the beam towards, almost in a horizontal manner. Okay, so these are the types of propagation modes in an optical fiber. The explanation is the one that I have just written in this slide. Now the next is the fiber size. In what are the different types based on its size? So fibers are defined by the ratio of diameter of the core to the diameter of their cladding. So I have told you have got two things. One is the core and the other one is the cladding. Now what is the diameter of the core and what should be the diameter of the cladding? Usually it will be specified in micrometer. Now if the type is 50 bar/125, the meaning is the core diameter is 50 and cladding diameter is 125. That is one type of fiber. So the mode that it uses is the multi-mode graded index mode. Now the other type is 62.5/125 micrometer. 62 is the core diameter and 125 is the cladding diameter. That also uses multi-mode graded index. And 100/125 and also 7/125. So these are the different types of fiber sizes. Okay, now what are the light sources used for optical fiber? See, you know what is the importance of optical fiber is to direct a beam of light from your source, from the center side towards the receiver side. Now, what is the type of the light source you have to make use of? Here, the sending device must be equipped with a light source and the receiving device with a photosensitive cell or called a photodiode that is capable of translating the light to an electrical signal. You should have a light source at the center side and you should have a photodiode at the one which it converts the light to an electrical signal. You can call it as photodiode and you at the receiver side. Usually the light source, it can be a LED or a injection laser diode. LED is light emitting diode, or you can have an injection laser diode at the center side. Okay, so this is about the light sources of optical fiber. Now, the transmission characteristics, LED, it is cheaper, you have a wider operating temperature range, and it lasts longer. But when you are taking the case of laser diode, it is more efficient and you are having greater data rate. Okay, now, what are the types of connectors in fiber optic cable? In twisted pair, what was the connector used? In coaxial cable, what was the connector used? And similarly, you have connectors in optical fiber to connect fiber optics to devices. So you have got SC connector, called it as the subscriber channel connector, which is used in cable TVs. Okay, it is a push-pull locking system. The other type of connector is ST connector. ST means straight tip connector. It is used to connect cable to networking devices. If you want to connect it to networking devices like routers or bridges, you are making use of this cable. Now, the third type of connector is MT-RJ cable. It is a new connector with the same size of that of RJ45. Okay, so these are the type of connectors used in used to connect fiber optic cable to devices. Okay, so this much I am telling it once again. So I have told the working principle, what property it makes use of. It uses the properties of reflection. You have a central core and you have a cladding, and the what are the different types of propagation modes of optical fiber, that is multi-mode and single mode. Multi-mode you can categorize into two, step index and graded index, and what is the difference between all the three. What happens in multi-mode step index, what happens multi-mode graded index, and what happens in single mode. Okay, now also I told about fiber sizes. It is depending on the diameter of the core and the cladding. You have got different types like 50/125, 7/125, etc. Now, in order to produce the beam of light, you should have light sources at the center side, and the light sources can be an LED or a laser diode. And these are the transmission characteristics of this LED or the laser diode. And similar to that, all the other cables, this fiber optic, you have got connectors called SC connector, ST connector, and MT-RJ connector. Understood this much? What are the different types of guided media? Twisted pair, coaxial cable, and fiber optics. Understood?
Yes, miss.
Yes, okay. Now, the next thing is the construction, fiber construction. Now, you are having the outer jacket. The outer jacket, it is actually made up of Teflon or PVC, polyvinyl chloride. So outer jacket, it is made up of PVC or Teflon. Now, inside the jacket, you are having some strands. You can see in the diagram that is called it as duopond Kevlar. Kevlar strands. Actually, that is used to strengthen the cable. Okay, now below the Kevlar, you have got another plastic coating in order to cushion the fiber. Now you have got the fiber at the center of the cable, and it consists of the cladding and the core. So this is how the construction. You are having an outer jacket. You are having inside of the outer jacket, you have got, in order to strengthen, you have got Kevlar strands. And below that Kevlar, you have another plastic coating. And finally, you are having the fiber at the center of the cable, and also you have got the cladding. Okay. Now, what are the advantages and disadvantages of this optical fiber? That we will see it in tomorrow's class. Tomorrow, first hour I have got. So by 8:25, you should be online to the class. And tomorrow, as I told, 2 questions I will be asking out of the 6 questions which I have sent through Linways. Hope everybody got that questions. Yes or no?
Yes, miss.
Yes or no?
Yes.
Yes. So study in such a way that you are preparing for the university examination. Some things what I have noticed is, like, few are writing the content of the slide. There is no perfect sentence you are noticing. I mean, the assignment also simply just writing it and going. You don't have any specific like what to say. Referring something and just going on writing. That is not that is a good habit. You have to just understand the concept, make your own sentence and write. And as I told in the morning class, representation, figure representation is very, very, very important. So whichever possible diagrams you can add it, you have to add it to the questions. Okay, as an example, OSI model I have asked. How many of you have drawn that different layers? Everybody has written the contents like application, presentation, session and all. But did you draw that diagram? Layer 7, application 6, like so. The diagram, see, once we are correcting the paper, see, we won't be reading the contents in a more manner. But once the figure is there, we can understand that okay, the concept is there in that paper. So try to include more number of figures in. So that doesn't mean that you should spend all the time in drawing. So minimize the time. If the question is answered for 15 minutes, means 5 minutes you take for the diagram, and the remaining 10 minutes you have to go on writing the theory part. Okay, let me check all the assignments. I will be updating the marks in it. So if you have not drawn the diagram for this time, I have reduced the marks. But be ensured that it should not be happening in the next assignments and all. And tomorrow, don't bluff the things in the answer sheet. You have to read the textbook carefully. 6 questions, you have to note down the points. What is the important point in each thing, and you have to write it. Okay. So tomorrow, I have told, as I had told, the different students, I mean 4 or 5 students has to give a summary of today's class. So thank you. We will meet tomorrow. Okay.
Thank you, Mr.